Okay, we're going to take a look at turbojet engines, they're used in aircraft propulsion, and the middle part is exactly the same as the Brayton cycle. It just has a diffuser and a nozzle, and the point of this is not to produce power, but to have a large velocity going out the back, acting as thrust. Okay, so the first step in a turbojet engine is, as the air comes in, we need to decelerate because that plane is flying very, very quickly. We need to slow that down so we can put it through the compressor, the combustor, and the turbine. So we call that the ram effect. Okay, and it does this isentropically in an ideal situation. So I'm going to be talking about the ideal turbojet here. So again, these middle three are all ideal. So I have an isentropic compressor, followed by the combustor, followed by the isentropic turbine. Okay, so again, those are what was in the Brayton cycle: compression, heat in, and then the turbine. Now, with the turbojet, the focus of this is not to create a lot of power. So really, the turbine only develops enough power to drive the compressor. All the rest of the energy is going to be used to create the thrust. Okay, so unless it states otherwise, we're always going to assume that the turbine simply drives the compressor. Now, I have all these as isentropic. Clearly, they can have efficiencies and things like that we can take into account. But again, the ideal is that they're all isentropic. And just remember that the turbine simply drives the compressor unless otherwise stated. Okay, and then at the end, I have the nozzle, also could be isentropic, could have an efficiency. And what it does is it accelerates that air to a high velocity, shooting it out the back and giving you the thrust that you need to propel the aircraft. Okay, so that's basically the turbojet in a nutshell. It's just our Brayton cycle with a diffuser on the front and a nozzle on the back, and it refocuses to increase the velocity and give you thrust through the nozzle to propel the aircraft forward.